In this lesson, I am focusing on the type of function, even, odd, or neither one. Okay, this is the question. We have a function here, y is equal to 3x to the fourth plus 2x to the second minus 3. Okay, why, when this is even, if this is even, we should have like this. F of x equals exactly to f of negative x. If this is even. Just we can prove this one. If this is even, we don't know. Okay, this is f of x. F of x is equal to 3x to the fourth plus 2x squared minus 3. Right? Okay, how about f of negative x? Instead of x, we can write negative x. What is this? F of negative x is equal to 3 times negative x to fourth, 2 times negative x squared, negative 3. How much is going to be? Negative x to the fourth, negative times negative times negative times negative gets positive, you know, because this is even. Okay, this is the same as 3x to the fourth. Here too, negative x squared, negative x squared is negative x times negative x gets positive x. Okay, plus 2x squared, because negative times negative gets positive. Negative times negative times negative times negative positive. This is constant. Constant doesn't do anything. Okay, what is this? This is exactly right like f of x. So we can, this implies that f of x is exactly equals to f of negative x. So this function is even function. Okay, and this f of x is even function. Right? Great. And how about the graph? Sometimes you don't have this one when you have graph. In general, if you have a graph like this one, okay, this quadratic, this is not quadratic, this is to the fourth, but if you have, for example, something like quadratic like this one, vertex is exactly here at y-axis. If you have f of x is this is even, because your function is exactly symmetry to y-axis. Or if you do this one, this is symmetric over y-axis, exactly. Any point goes to y, and this one the same. This is even function, must be like this or this one, doesn't matter which way. Okay, this is even because this is symmetric to y-axis. But if you have somewhere else, for example here, this one, this is parabola, the leading coefficient is negative. This is symmetric, but not to y-axis. This is symmetric to this line. X is equal to somewhere, yes? But not y. This is symmetric, but not over y, somewhere else. Okay, this is not even. Even we say when is symmetric to y-axis. Okay, and the odd, for example, if we have an odd, what is the parent function of y to the 3? X to the 3. This is like this one. This is parent function for this. F of x is x to the 3. Okay, this is odd because it's not symmetric to. This is symmetric, but symmetric to origin. You know, to one point. Any point to origin goes to other way, the same way. Okay? The same distance. But not to y-axis. This is odd function. Odd function is symmetric to one point, not to y-axis. Okay? And if this is neither one is not symmetric to y-axis, not to origin, nowhere, just goes different. They say neither one. Okay, hope you like this and see you later. Bye.